Good afternoon everyone and welcome to our video presentation. I am Ansar Badane. I am pursuing B from KG College of Engineering and Management Research Pune, and along with me is Manush R. So in this video we both are going to explain the project, what we learned throughout the whole internship, and in the end we'll also demonstrate our projects which we completed during this MRZ IoT internship. So the title of the project is IoT based home automation system. These are the contents of our presentation. So let's start with the introduction. Home automation. So basically home automation is a concept that primarily encompasses the ongoing R&D and implementation towards controlling the everyday electric home appliances with a tip of the finger remotely. This encompasses optimum energy use, enhanced energy conversion, affordable lighting solutions, security solutions, centralized home entertainment systems, etc. Home automation based on IoT or Internet of Things, which will use cloud-based computing or Internet protocols (IPs) to control all devices in a smart home. So what did we learn throughout the whole internship? So C programming. C is a general purpose procedural middle level language as it supports both low level and high level functionalities. Some of the advantages of C is that it is easy to understand, it is portable, and it has fast compilation and execution time. They also covered basics of C++, which is an extension to the C language, and it supports object-oriented programming. The best thing about this internship is that they taught us C language from scratch, so we didn't need any prerequisites. These are the attributes of the project. The first is monitoring. It means that user can check in on their devices remotely through an application. Second is controlling. Controlling means that a user can control these devices remotely, like panning a security camera to see more of a living space. Automation. Automation means setting up devices to trigger one another. Then cloud computing, and at last we have safety. Safety means there are many smart security products that can increase your home safety, like sensors for doors and windows, cameras that can detect people, and video doorbells that let you greet whoever's knocking from anywhere with the internet. So this is the flow diagram of a project. As you can see, we have used Arduino Uno board, which is an open source microcontroller board based on microchip Atmega 328P, and we have interfaced it with the home appliances that we want to control, and we have also interfaced it with the W5500 Ethernet, which will help us connect wirelessly to the Blink cloud server, and it provides easy internet connection, and we can control the Blink cloud server through the Blink mobile application. Internet of Things, IoT. IoT is a network of interconnected embedded devices that can capture and transmit data without the need for human interaction over a wireless network. These are some of the features of IoT: endpoint management, automation, security, integration, active engagement, as well as connectivity, scaling, sensing, analyzing, and artificial intelligence. Embedded systems. As its name suggests, embedded means something that is attached to another thing. Embedded system basically is a system which composes of hardware as well as software and real-time operating system. It can be small independent system or a large combinational system. For example, a fire alarm is an embedded system. It will sense only smoke. These are some of the features of embedded system. You can go through it. Software requirements of the project. So the first one is Arduino IDE. It is an open source software that makes it easy to write the code and upload it to the board. This software can be used with Arduino board. The second is PiximLab. PiximLab is a real-time emulator of development boards with MPLAB, X, AVR, GDB debugger interaction. Some of the features of PiximLab is that it is a real-time emulator and it supports Arduino. PiximLab also supports some Pixim microcontrollers and SimAVR microcontrollers. So this is a screenshot of PiximLab user interface. This is the spare parts window to be more specific. And the third application is Blink IoT application. So Blink is an IoT platform for iOS or Android smartphones that is used to control Arduino via the internet. Blink is low-code IoT software platform for connecting devices to the cloud, building mobile apps to remotely control and monitor them, and managing thousands of users and deployed projects. This is how the Blink user interface looks. We also have options to customize and add widgets and switches and gauges. So conclusion, main purpose of home automation system is to provide ease to people to control different home appliances with the help of Android application present in their mobile phones and to save electricity, time and money. The home automation using IoT has been experimentally proven to work satisfactorily by connecting simple appliances to it and the appliances were successfully controlled remotely through the internet. So now we'll demonstrate our projects, but before that we'll go through the functional requirements of the project. The home automation should be simulated on the PiximLab simulator. A Blink IoT mobile application used to control the devices should be able to control the lights, temperature of the home, inflow and outflow of the water in the water tank. The functional requirements of our project is controlling the garden lights, controlling the temperature, water tank inlet and outlet valve control. So this is the PiximLab software, and here we have Arduino Uno board. So we have serial communication port, we have the reset button here, and the Arduino Uno has 14 digital input output pins, of which 6 can be used as PWM outputs. It also has 6 analog pins and 16 MHz ceramic resonator. We have to interface the devices with Arduino and simply load the hex file which is created from the code. So these are the devices. This is the LED, this is the LDR sensor, this is the temperature system, heater and cooler basically, this is the Ethernet W5500, and this is the LCD, liquid crystal display. So if we load the project, it should display the temperature in Celsius. It also displays if cooler is on or off. It displays the volume of water in a water tank and inlet flow on, outlet flow off. It should display it here. As you can see, if the LDR sensor, we can control its intensity. You can see here the light is more intense, and if we lower the resistance, the light decreases. So this is the serial remote tank. We have to connect it with the serial port, and once we connect it, we can simply check uh, how much more water is present in the tank, and we can automate it by programming. If the water goes below 2000, the inlet valve automatically gets on. So this is the blink application screenshots. Here we have the cooler button, heater button, and the temperature gauge, and we have two tabs. So basically, if the temperature is above 35 degrees Celsius in the notifications tab, so the heater automatically gets turned off, and if the tank is full, so the inlet valve is automatically turned off. So now we'll run the project live. So this is the code. As you can see, these three, the blink template ID and authentication token, we have used that to connect to the blink application, and this is for the LDR, the main, this is for serial tank, and this is the code for temperature system. So basically we have to create a hex file of this and dump it into the Pixim lab. Thank you, Amazi, for this wonderful opportunity.